Welcome to all. I'm the course coordinator of Digital System Design. Today's topic, sign magnitude binary numbers. At the end of this session, you'll be able to understand what is a sign number, what is an unsigned number, how to represent the negative numbers, how to represent a positive numbers. So how to represent a number in signed and unsigned form. What is a representation? So first of all, what is a data representation? We can represent a data in a form of magnitude and in the form of complements form. So the data representation is can be classified into two types. One is a magnitude, other one is a complements. Magnitude, we already learned about the complements form. So in this session we learn how to represent a number in a magnitude form. Magnitude, there are two types of magnitude: unsigned magnitude, signed magnitude. Unsigned magnitude, it is used to represent the data only in the positive numbers. Then by using this unsigned magnitude, we can represent a positive number only. We cannot represent the negative numbers. The name itself indicates that this is an unsigned magnitude. Unsigned, there is no sign for this number. So defaultly, if the sign is not present for the number, we can take it as a positive number, so that we can represent a positive numbers by using this unsigned magnitude. Here for this example, if you observe this example, 12 can be represented as a 110, but minus 12 we cannot represent. Why? Because this is my negative number. Then the next one is a sign magnitude. It is used to represent the data in both positive and negative numbers. We can represent the data in both positive and negative numbers. So by using this sign magnitude numbers, we can represent the 12, and also we can also represent the minus 12. So let us see one example how to represent a number in a sign magnitude form. So in this example, it is an 8-bit number. So in an 8-bit number, 1 bit is a sign bit, the remaining 7 bits are magnitude. 1 bit is a sign bit, the remaining 7 bits are magnitude. What is which location is a sign bit location? There, if in every number, in any bit number, if it is an n-bit number, 8-bit number, 3-bit number, 4-bit number, whatever an n-bit number, the MSB bit is in a sign bit. You have to add the sign bit after the MSB of the magnitude. MSB bit of the magnitude number. So if it is here in this example, here we are considering the 8-bit number. This is an 8-bit number. So what is an MSB of an 8-bit number? D7 is an MSB of this 8-bit number. D0, D1, D2, D3, D4, D5, D6, D7. This is an MSB of this number. So sign bit always an MSB bit of this number. So remaining was a magnitude. This is the sign magnitude representation. The MSB is a sign bit, and remaining are the magnitude of the respective number. So let us consider a one number 41. 41. First, if you want to represent any number, decimal number into a sign form, first you have to convert this 41 into a binary. So first, by using this successive division method, you have to convert this number 41 into a binary. So after converting this 41 into binary, you will get in a 0, 1, 0, 1, 0, 0, 1. So this is the magnitude of this number. So if this is a positive number, so you have to add in the sign magnitude form, you have to add in a sign bit. This is in a positive number. So what is in a sign bit of this positive number? For a positive number, the sign bit equal to 0. So you have to add in a 0 for this to represent a positive number. So this is the magnitude number. Add an extra bit after this MSB, that is an sign bit. This sign bit for this 41, the sign bit equal to 0 because 41 is a positive number. For a minus 41, same procedure. First, take the 41, convert this 41 into decimal 41 into binary number 0, 1, 0, 1, 0, 0, 1. Then add a sign bit. To represent a negative number, the sign bit equal to 1. So that here the MSB bit equal to 1. 1 0 1 0 1 0 0 1. So in this way we can represent the positive number, represent the negative number in a signed magnitude form. Then one more example, 6. 6, here we consider the 8-bit number. So that only we are writing all the zeros for this number. So 6 for the 6, 0, 1, 1, 1, 1, 0. To form an 8-bit number, sign bit is a D7 location. The remaining bits are 0, 0, 0. So that the 6 can be represented as a 0, 1, 1, 0, 0, 0, like this. So what is an assigned bit? This is a plus 6 only. So that the sign bit equal to 0. Or minus 14. 14, 1, 1, 1, 0. Remaining locations are 0. The sign bit equal to 1. Why? Because this is a negative number. So that the sign bit equal to 1. 24. The binary equivalent of this 24 equal to 0, 0, 1, 1, 0, 0, 0. By using a successive division method, we can convert this decimal number into a binary number. This is the binary number of this 24. Then add a sign bit to after this MSB. So this is the sign bit. The sign bit equal to 0 because 24 is a plus 24. Similarly, 64 minus 64. 64 is a 1, 0, 0, 0, 0, 0. Then add a sign bit. This is a minus 1, minus 64. So the sign bit equal to 1. The representation of the sign numbers using ones complement. So how to represent a numbers, sign numbers using ones complement. So if ones complement representation is used to represent the both positive and negative numbers. Why? Because these are the sign numbers magnitude form. So by using this ones complement representation method, we can represent both numbers. So how to represent numbers? So in order to represent a positive number, there is no change. There is no change. We as in a sign magnitude form, we can represent in a positive number in a ones complement also. So plus 6. So plus 6. The what is in a binary value of a 6? 1, 1, 0. So we have to add in a sign bit after this MSB. In a previous one, we took an 8-bit number. That's the reason we add in zeros. Here we are didn't taking any 8-bit numbers. We just write a 6, 6. So here 6 is a 1, 1, 0. So add in a sign bit after this MSB. So here MSB is 1. So add in a sign bit after this MSB bit. Sign bit will become an MSB. So here 6 is in a positive 6. So that the sign bit equal to 0. Next, minus 6. If you want to represent a minus 6, keep it in mind. If you want to represent a minus 6, first place the 6 magnitude as it is 1, 1, 0. 1, 1, 0. Okay. Then this is an what is this? Plus 6. Plus 6. The sign bit equal to 0 for plus 6. So if you want to represent a minus 6, the sign bit equal to 1. Then you keep the sign bit as it is. Keep the sign bit as it is. Take the ones complement of this the number. Take the ones complement of the number. 1, 0, 1, 0, 0, 1. So this is the ones complement representation of minus 6. So let us take in another number, plus 51. So 51, take the 50, convert this 51 decimal number into a binary number 110011. So add 0 as a sign bit. Why? Because it is the sign of this 51 is a plus. Next step. If I want to represent a 51 in a ones complement, then sign bit equal to 1 for a minus 51. So 1. Remaining thing, what is a 51 plus 51 is having? To make these terms as a ones complement. 1 become a 0, 1 become a 0, 0 become a 1, 0 become a 1, 1 become a 0, 1 become a 0. So this is the representation of minus 51 in a 1's complement. If you want to represent a minus 51 2's complement, take the 1's complement for this only. Don't take the sign bit. Don't change the sign bit. Take this form, add 1 here. Then you will get a 0, 0, 1, 1, 0, 1. So that is a representation of minus 51 in a 2's complement. This is a sum of examples for to represent a signed binary numbers 0 to 7, 0 to 8. So this is a sample questions to represent a signed numbers. So to represent the numbers in sign magnitude form. Thank you.